Right, get upset. I want to learn some more.
Yeah, right.
We're done learning. We're just reviewing, aren't we?
Yes, sir.
Aren't we, Foreman?
Yes,
We're just reviewing. This should already be here. We're just reeling everybody in for that focus for tomorrow. And they're right there, Ruiz.
yes, sir.
Perfect. Intro regulators, that's where we left off. The first part of the lesson, before we even got into the regulator itself, that is the series voltage regulator, there were some terms and definitions and formulas. Let's remind ourselves of what these things are. Oh, how about blue? Yes. Percent of regulation.
How well?
What does that mean, Mr. Ramos?
How well the regulator works?
That's the bottom line right there. That percent of regulation, when we find it via formulas, tells us how well the regulator actually works. Easy enough. How regulator works. I guess that's like broken English or something. How well the, wow. How well the regulator works. Basic, down and dirty definition. That's what the percent of regulation tells us. How do I know how good the regulator is? What does the percentage tell me, Mr. Petracek?
Closer to 0, the better the regulator is.
Yeah, I'd write that down. Closer to 0 what? Percent. Better. So if I have a 0% regulator, what does that mean?
Perfect.
That's like the shizzle. Yes. All right. Yeah, it'll never happen because it's not a perfect world, is it? No, we'll never have everything perfect. Purpose of a regulator, though, there's that definition again, Ms. Sanchez.
To maintain nearly constant output, voltage or current despite changes in variation in the line or the load resistance.
How many times have I written this up?
A lot.
Oh, there it is. I'm going to write line voltage and also input voltage next to it because I told you this morning they mean the what? Same thing. Same damn thing. So what's the deal? So by the time we get to the fourth stage of our power supply, we're at the regulator stage, and I want to maintain a nearly constant output. Doesn't matter if it's voltage or current. Doesn't matter. Doesn't matter if I feel some type of fluctuation in the line way down here. It doesn't matter if I go over here and I plug something else in. Bottom line is the output's supposed to be maintained nearly constant. That's the deal. It's the whole purpose. Some formulas. Percent of line regulation. What is that formula, Mr. Ramos?
Voltage output max minus voltage output minimum divided by voltage output minimum times 1.
This ringing a bell?
Yes,
sir.
All right, times 100, right?
Yes, sir.
So we're trying to find a percentage. Must have to multiply by 100 or move the decimal places. 2. V out max line, V out main line divided by V out main. Look, I put the word line in parentheses because you might see line or just max or min. It's the same thing. It's talking about the line, the input. So if I go to the output and take a voltage reading and I see 5 volts, all right, good. It's supposed to be around 5 volts. Then I go check it again, something happened, it's like 5.1 volt. Don't I take the big number minus a little number, 5 by little times 100? Does that result in the easy equation?
Yeah.
Big minus little divided by little. Wow. Times 100. Percent of load regulation and line regulation is basically the same formula, isn't it? Sure. Or you take the big number, subtract the little number, divided by the little number times 100. But percent of load regulation specifically is what? V out what? Somebody different. Roads, thank you. Hallelujah. V out what?
No load minus full load divided by full load times 100.
Oh, just full load?
Voltage.
Oh, yeah, I know what you mean. Times 100. So no load means what? What does that mean? No load means somebody different. How about Mr. Ruiz? What does no load mean?
There is no load.
Okay. There is no test tomorrow. I got you. Made you look and say, what? Yes.
But it would be short, so it would be max current.
Huh?
Yeah.
No load means I unplug that gyro mouse.
Okay.
And full load means, yeah, like an open.
Full load means there's a load connected.
Right. So here's the thing. If I unplug that gyro mouse, open, it's like max what? Max voltage, max resistance, but the output should still remain relatively constant. Everybody understand what I mean?
Yes, sir.
I did this a couple times now. This thing needs 6 volts to operate, 6 volt DC. You think there's probably about 6 volts DC of potential there just hanging out? Yes, that's what it means. No load. Full load, I got to plug back in. So, to help you remember that no load is the big number, it's like an open. Max voltage, max resistance, right? That should tell you, oh, that's the big number. Full load, now I'm loading down a power supply, the output's going to drop slightly, but it's still maintained relatively constant. Good?
Sir.
So if I gave you, hey, 10 volts and 11 volts, 11 minus 10 divided by 10 times 100, how much of a change is that? The amount of change is 1 volt. How good of a regulator is that, though? Somebody do it. Let's see what percentage we come up with. 10 volts and 11 volts. Those are your two values.
10%.
10%? Is that a decent regulator?
No, sir.
It's all right. But if you're talking about a volt, a whole volt to change, your circuit still might operate the way it's supposed to, but the goal is to be as close to 0% as possible. Is the horse dead on the percent of line load regulation, big minus load divided by load, the easy formula? Definitions? Good?
Yes, sir.
All right, make sure you know it.